Hello everyone and welcome to this session called Introduction to Building with Motoko. My name is Sebastian, I am Education Lead at Code & State, a venture studio building on the internet computer. In this video, I will introduce you to the Motoko programming language. It's a new language that you can use to build decentralized applications on the internet computer. Why should you learn Motoko? Whether you want to build a game, a social media application, a DeFi application, a messaging application, or you just want to build an application, you can do it with Motoko. With Motoko, you can build almost any application that you want on the internet computer. And if you are interested by Motoko after this video, you can also join Motoko Bootcamp, which is a one-week program that I run every month, where I teach you how to build a DAO on the internet computer. You will join other builders and you will learn and build together. If you're interested, check out www.motokobootcamp.com. The internet computer is a decentralized cloud. You can think of it as a mix between a cloud and a blockchain. The cloud is necessary for running application, and the blockchain part is necessary for the decentralization of this cloud. On the internet computer, you can build decentralized application, also called dApps. Decentralized applications are applications that are owned by communities and users instead of owned by big corporations such as Facebook, Google, or Amazon. Why does the internet computer matter? Well, on the internet computer, you can create applications called dApps and put those applications under the control of a DAO. A DAO is a decentralized autonomous organization, which is also an application running in a fully transparent and decentralized manner. Once you have a DAO, you can have investors, users, and developers collaborating together for the application without having a company that controls the application, which means that we can now collectively own and control software, which is a game changer, and this is what I talk about and teach in the Motoko Bootcamp. If you want to know more about how the internet computer works, I have created a dedicated playlist called Understanding the Internet Computer, where I dive into the technology that makes the internet computer possible, the consensus and the protocol, and the cryptography behind the technology. As I've said previously, on the internet computer, you can build any kind of application. You could build a messaging application like OpenChat. You could build a social network application like Discover. You could build a decentralized finance application like ICP Swap, or you could build a game like Dragons. All those applications are built using what's called as a canister. A canister, as you can see here, is a mix between the code for your application and the state of your application. The code of your application is a WebAssembly module, and the state of your application corresponds to the WebAssembly memory. On the internet computer dashboard, which is an important dashboard that captures and collects all metrics related to the internet computer network, we can see the number of canisters deployed on the network. Currently, as I'm recording this video, we are January 2024, and there are 377 and 381 canisters deployed on the internet computer. If you are familiar with Ethereum and other blockchain, you can compare canisters to smart contracts. If you are familiar with Docker, you can think of canisters as containers. And if you are familiar with none of the previous environments, you can think of canister as a mini computer that stores all the code, all the variables, function, assets necessary for your application. For this video, I'll make a prediction. I believe that eventually everyone is going to have their own canister containing their own data. Canisters combine the properties of smart contracts, the properties of containers, and the properties of computers. Before we write our first lines of Motoko, I would like to show you how things work when you interact with an application deployed on the internet computer. The application that I'm using today is called OpenChat. OpenChat is a messaging application fully built on the internet computer. It's actually the first application that was controlled by a DAO. And I'm also using something called IC Inspector, which is a Chrome extension that you can use, and it will monitor all interaction between your browser and the internet computer. We have this Motoko Bootcamp group, and I'm going to send a message and show you the interaction that happens between my browser and the internet computer. For that, I will inspect the web page and open the IC Inspector. So the IC Inspector is on, as you can see here, and it's recording every interaction. As you can see, we have a few interactions going on already. Now, notice what happens when I send a message. As you can see, this new function has been sent called send message. It's update, and there is a canister ID here, which is actually the canister ID that I'm communicating with. So every interaction with the internet computer is actually a call to a canister. So as we've seen, any application built on the internet computer runs inside a canister. Every interaction that you have with the network is a message that is sent to a canister. An interaction can be posting a message on social media, transferring a token to a friend, or even just reading your messages on a messaging application. All those messages are processed by the canister, and an answer is returned to you. Alright, let's deep dive into exactly what a canister is. Don't worry, we'll explain every single part of this picture. When I started and discovered the internet computer, it took me several weeks to understand what a canister was. Don't worry, I'll make it short for you and explain in 5 minutes everything you need to know about what a canister is. Okay, so we've said that a canister is divided into two parts. The first part is the WebAssembly module, the second part is the WebAssembly memory. The WebAssembly module corresponds to the code of the canister. This code comes from the code written by developer in language such as Motoko, Rust, TypeScript, or even other programming languages that compiles to WebAssembly. Once developers have written their code, the compiler of the specific language or other related tooling will compile this code to a WebAssembly module. Then this WebAssembly module is installed inside the canister. If you want to upgrade a canister, you need to change the WebAssembly module. The WebAssembly memory contains the state of the application. Anything like token balances, user profiles, NFT, files, assets stored in the canister are stored in the WebAssembly memory. The WebAssembly memory can be modified through the WebAssembly module. The code can affect the memory. Canisters require cycles. Cycles are like credits. Cycles are used to pay for computation and storage costs of canister. Each canister has a cycle balance. Usually, developers will pay and charge their canisters with cycles. If a canister runs out of cycle, it can be deleted by the internet computer. Note that also users and other canisters are able to send cycles to other canisters. Okay, let's move to the user side. We can interact with canisters only through public functions. It's important to understand that the memory of a canister is not exposed by default. Otherwise, anyone would be able to see messages and interactions happening on the internet computer. A canister can only be accessed through these public functions. Developers will specify public functions when writing their code, and those public functions can be used either to execute the WebAssembly code or to look into the WebAssembly memory. For example, post message would be a public function, read message would also be a public function. Those public functions can be called from different places. Actually, any canister on the internet computer can call other public functions of other canisters through intercanister call. Also, developers can use something called defix, which is a command line tool that we will use during Motoko Bootcamp, can be used to call any public function of any canister on the internet computer. The candid UI is a specific interface that is generated automatically and contains a list of all the public functions of a canister. This candid UI can also be used to call those public functions. Finally, and that's how most users will interact with canisters, a frontend can be used to call public functions. For instance, when I was using OpenChat, the frontend was loaded in my browser, and when I sent my message, the frontend sent a request to the canister. Public functions will execute specific code in the WebAssembly module, and this code can change the memory or read the memory. Applications built on the internet computer can use one canister or multiple canisters for different purposes. For example, an application could have a canister for the backend and a canister for the frontend. Now, and especially if you're starting your developer journey, you might be wondering, but what is exactly WebAssembly? We keep talking about this WebAssembly module, but what is WebAssembly? WebAssembly is a virtual machine for the web. It enables developers to write application in multiple languages such as Motoko, Rust, TypeScript, Java, and have it compiled in WebAssembly. WebAssembly runs on almost all possible devices: browser, server, computer, IoT devices, and on the cloud. WebAssembly compiles to a binary format, which is both efficient and extremely fast. Yes, WebAssembly is an amazing technology, and it's a huge component of the technologies that makes the IC possible. If you want to know more, I will put some links in the description, and I also have a dedicated video for WebAssembly if you want to dive more. So, if WebAssembly is so amazing, why don't we write our canister code directly in WebAssembly? Well, in theory, you could use WebAssembly. This is an example of a counter that was written in WebAssembly. Counter.what? What means WebAssembly textual format. There is a textual format that is actually converted to the binary formats I mentioned. And this example comes from the definity/example repository, which is a repository containing many examples for the internet computer, for Motoko, Rust, and even WebAssembly. This is actually the only example that is written in WebAssembly. This is because, as you can see, this is only an application that stores a counter, increment a counter, and where you can read the counter. And it takes around 106 lines to write this in WebAssembly, and also the code is really hard to read because WebAssembly is a low-level language close to binary or assembly. And so that's why a developer needs an abstraction to work on top of it. There was no language dedicated to WebAssembly and the Internet Computer, and that's why Dfinity, the foundation behind the Internet Computer, decided to create Motoko. Motoko is the first language and the only language dedicated for the Internet Computer. If you're excited about ICP, you need to learn Motoko. 2 years ago, I decided to learn Motoko, and it was one of the best decisions that I ever taken in my life. Oh, in case you're wondering where the name Motoko comes from, I'll let you have a look at the Ghost in the Shell wiki /Motoko Kusanagi page. Okay, let's start to write our code and start to build our application. I would like to introduce you to the Motoko Playground. The Motoko Playground is an online coding environment for Motoko that we can use to deploy canisters completely for free and without having to set up anything on our machine. We will deploy in a special part of the Internet Computer called the Playground. On the Internet Computer, if you want to deploy applications, as I said, you need to buy and pay for cycles. On the Playground, we can deploy for free. The Playground has some limitations. Any canister will be deleted after 20 minutes, and also we cannot deploy cycles. We cannot send cycles to other canisters, and you can probably imagine why. Okay, so the first thing is to click on New Motoko Project, and it will open a main.mo file, main.motoko, and a blank editor. Okay, so let's take a look at the application you will build today. The Candid UI is a visual interface that enables us to access the public interface of the canister. Of course, I have already deployed this canister, that's why we have access to the Candid UI. So the canister that we want to build today has a simple function. The function is to store a message, and we have one public function that enables us to see the message that is stored, and one function that enables us to change the message. As you can see, the changes are reflected. Also, there is another function which essentially returns the number of times the message has been changed. So in our case, just one. Let's start with a very important rule. Any canister written in Motoko always starts with the keyword actor and brackets. The entire code that you are going to write, all the functions, all the variables, will fit inside the two brackets. Why actor? This is because a canister is abstracted as an actor in Motoko. Actor comes from the actor model. Here is a simple animation that explains the actor model applied to canisters. Imagine that you have two canisters, canister A and canister B. Canister A stores a counter. Canister B wants to access the value of the counter. Unfortunately, canister B cannot directly read the state of canister A. And that's why canister B will have to send a message to canister A. One thing that can happen is that canister A receives another message, because actor can send messages to other actor. Canister A will treat the first message, increment the counter, and then treat the second message, get counter, and return the value of the counter to canister B. We need to define three variables. We need a variable to store the message. We also need a variable to count the message, and we need a variable default message. The default message will be used in case message is empty, so we can notify our users. Before we define our variables, we need to understand that Motoko is a typed language. This is an extremely important part of the language, and this is what makes Motoko a safe language. So let's say I define a variable called n, and I assign it a type nat and a value 0. So in case you're wondering, this is the type assignment operator, and this is the type I assign this variable. Nat stands for natural numbers, which are all the numbers from 0, 1, 2, up until infinity. Once I have specified n as a nat, I can never use n for operations that require another type, like a text or a boolean. There are many types in Motoko, but for today we will only care about two types, which is the type nat, as we've seen, and the type text, which enables us to store textual messages. The first variable that we want to define is the message. We need to use the keyword var, because in Motoko, variables defined with var are mutables. But variables defined with let, as I've done previously, are not mutable, they are immutable. Immutable means that you can never change the variable. In the case of the message, we want to be able to change it, so we use var. We can specify the type of type text, and we can set an initial value for the message. At the end of any variable declaration in Motoko, you need to add a semicolon. And that's our first variable. We can add a comment with 2/, store the message, mutable variable. The second variable that we need to define is the counter for the messages. Count the number of messages. It also needs to be a mutable variable. In this case, it needs to be a counter of type NAT, and we can initialize it to 0. Again, don't forget the semicolon at the end of every variable declaration. The final variable that we need is the default message. The default message is an immutable variable. A default message in case the message is empty. Immutable variables are defined with let in Motoko. The value of this variable can never be changed. Now we need to write our functions. Note that today we will only write public functions, but private functions also exist in Motoko. Private functions would not be accessible from the Candid UI or from other canisters. The first keyword that we need to use is the keyword public. We need to specify that the function will be public. Then we need to use the keyword func, which stands for function, and then we need to specify the name of the function. This function will be change message. We will use this function to change the message and increment the counter. In Motoko, functions are also typed. Just like variables, functions are also typed. And that's why you need to specify the types of the arguments of a function and also the type of the return value. For the argument, we will set new message, which will be a message provided by the user, and this will be of type text because we want this value to be assigned to message, which is already of type text. Then we need to specify the return type, and the return type of a public function is always async and the type of whatever we return. If you're confused about the async, I suggest you watch the parts on the actor model, which explains that canister essentially communicate through asynchronous communication. It would be the same for canisters to user or canister to canister, and that's why we need this async. Then we need to specify the return type of the function. So in this case, it will be the unit type, which actually means nothing. So because we won't return any value for this function. And then we can open the brackets. Don't forget the semicolon at the end of the second brackets. And then we can specify the code of the body of the function inside the brackets. The first thing that we want to do is assign the value of message to new message. So in this case, the message will be changed, the value of the message will be changed to the value of new message. And then we can increment the counter by doing a reassignment with the plus operator. Every single operation needs a semicolon at the end. Finally, we can return. Note that in Motoko, we could forget to put the return, and this would still work because Motoko automatically returns after the last instruction has been executed. Just for clarity, we will leave the return. Note that we don't return anything, and that's why we have this unit type. That's our first function. Our second function will be a query function. And for that, I need to explain the difference between query and update. The first function that we wrote, change message, is an update function. An update function goes through consensus. This is because this function actually changed the states of the canister. As you can see, we changed the value of the message and we also changed the value of the counter. The next function that we'll write is a query function. A query function can be used when you only want to look at the states, but you don't want to commit any modification. A query function does not go through consensus and can be answered by a single node. This is why a query function is also very fast. Okay, so we want to create a function that returns the message. This is a query function, and it does not go through consensus. This one takes around 200 milliseconds. This one takes around 2 seconds. To define a query function, we need to add the query keyword between public and func. This function will not take any argument, so we can leave empty, but it will return a text corresponding to the message. And we can simply return the variable message, and that's it. The last function that we want to create is a function that returns the value of the counter. This is a query function that doesn't use consensus. Oops. We also use the same syntax, public query func, C counter. We take no arguments, but this time we return a natural number instead of a text. And we can simply return the value of counter. One thing I forgot in this function is to actually test if the message is not empty. So if the message is empty, and this is how I can check, message.size is returning the number of characters in the message. If the message.size is equal to 0, I can return default message. Otherwise, we return the message. And that's it. We are ready to deploy. To deploy a canister on the playground, we simply need to click on deploy in the top right corner. After that, you can see those configurations. You can configure the name of the canister, and you can also configure the garbage collector. The garbage collector is useful for Motoko. We can stay with the incremental garbage collector and just click on install. Once your canister has been deployed, you will see a countdown appearing on the left. This countdown represents the number of minutes your canister will remain on the internet computer. Once the countdown is over, approximately 20 minutes, your canister will be automatically deleted. You can also see the canister ID, which is an identifier corresponding to your canister, and you can see the size of the WebAssembly module installed in the canister. On the right, we have the Candid UI. We can access the Candid UI in another tab by clicking here, and we can interact with the public functions of our canister through the Candid UI. I can see the message, see the counter, and change the message. Notice that those are query calls. They perform pretty fast. This is an update call, and it takes more time because it has to go through consensus. Usually, the playground is slightly slower than the internet computer because the playground is a specific part of the internet computer. I can see the counter being updated, and I can see a message here. And that's it. We've deployed our first application using Motoko on the internet computer.